just for us to start, do a little bit of introduction, and we can get into it. Hi everyone. Thank you again for joining this live demo call. Very good. I mean, we've done a number of webinars in the past, but this is actually the first live demo that we're doing specific for a feature, and I'm really excited about it. My name is Ayodele. I'm Product Manager at OpenFn. I have a poll up right now. Just also, I hope everyone to know what OpenFn is. We are the leading digital public good for workflow automation and data integration. We're trusted by governments and non-profit or humanitarian organizations in about 40+ countries around the world. And every year, we're trusted to, our platform is used by organizations to actually connect systems and then also automate, the complex and even simple workflows that are very repetitive, so that they can save time, save money, and drive efficiency across their various programs. We're really excited about this new feature that we're going to be talking about. And I have on the call here today Joe Clark, who is a principal engineer at OpenFn. So I'm passing the bit on to Joe to talk a little bit about himself, and then can get us straight into the live demo. Hey, Joe.
Thanks very much, Ayo. Hi, everybody. My name is Joe. I am, I'm not mentioned titles, but I'm the JavaScript guy at OpenFn. So I handle a lot of the JavaScript code, oversee a lot of job writing, adaptive design, and a lot of the runtime that powers the OpenFn platform. I am based in Cambridge, here in the UK. We are enjoying a very grey winter. It's not very fun here at the moment, but luckily we've got lots of nice work projects to keep me company. We're going to be talking about a brand new feature to OpenFn today called collections. But before we get started with that, I'll just give a little bit of introduction to OpenFn. I wonder if I can take over the screen share here.
Yeah, sure, that's fine.
I will just press, I think, this button. If you don't know what OpenFn is, if you've never worked with OpenFn before, then, well, you might just be on the wrong call. But just in case I got your back, I'm going to give you a little bit of introduction as to who we are and what we do. OpenFn is a workflow automation and data integration platform working in the digital public good space. And what we set out to do is we set out to integrate all the different platforms and systems that exist across the internet, really, but particularly in digital public goods. Systems like Primero and Comcare, DHIS2, Salesforce, Community Health Toolkit. There's so many systems out there which are doing really important jobs in healthcare all across the world, particularly in the global south. And these systems tend to be really very good at doing one particular thing. They're very good at doing their job, and as a general rule of thumb, the smaller, more focused a system is on one particular problem, the better it's going to do at solving that problem. Whether that's collecting surveys from users in the field, whether that's storing patient healthcare data, whether that's interchange formats or community management tools, or all sorts of things are out there, and they're really important to running our online and real world communities. But there are problems, because a system can only do so much, and systems form across the world more or less independently. And often systems need to speak to each other, just like people. Systems formed in very different spaces need to communicate. And when any of these systems kind of need to share information with each other, it can be very hard to know where and how to write and run code to share data, to convert data formats between different standards. And that's where OpenFn comes in my sketchy little diagram here. OpenFn is kind of at the center of the spider web. The idea is that we are a platform which will freely run your code. We run in a sort of JavaScript-like code language, and we provide a number of high-level helper libraries to make it easy to connect to all these different systems. And the idea is that systems talk to OpenFn. OpenFn merges and squashes and aggregates and converts the data into the right format for the right systems, and then it sends data to the next system down the line. And our workflows can be anything from a simple transformation from system A to system B to much more complex transformations between several distant systems. It could be to and fro conversations. There could be email notifications, alerts on different platforms. There can be error handling. There can be notifications to admins when things go wrong. There's a whole bunch of complexity that needs to be handled in a real workflow. And OpenFunction provides a number of tools and services, as well as a platform to do that. It's all open source. We have our own hosted platform at OpenFn.org, but it's a completely open source product, and we encourage and enjoy seeing people making their own deployments to solve their own particular integration problems. Now, up until now, OpenFunction has been very focused on taking data from system A and moving it to system B with no kind of storage solution of its own, which is where collections comes in. And collections is a new feature we're going to be talking about today. It's available to open source users and deployments only. We'll be rolling out onto our main app OpenFn platform soon in the new year, and to our deployments as well. But collections essentially is a key value data store which sits inside the OpenFunction platform itself, which means your workflows, when they take data and process data, they can freely write data to a collection. So if you're familiar with Redis, perchance, that speeds things up for you, because it's basically sort of our own implementation of Redis. Sounds like a big deal. It's quite a simple system, but it's a Redis-like system that sits on the OpenFunction platform. So a collection contains what we call key value pairs. I mean, it looks a lot like JSON. You might have, so a key is a name for a unique piece of data or ID. And the value technically must be any string value, but because we use JSON as a very common interchange format, and because JSON formats very conveniently to strings, then we tend to store a lot of JSON data inside our collections directly, just serialized to a string format. So you might have a very simple collection which has a key of name and a value of Joe, just a simple string. You may have a more complex value. Can I scribble here? No, I can't. You may have a more, oh yeah, I can scribble here. Here we go. Ta-da! You may have a more complex value where your keys have multiple bits of information in. So this key represents some kind of patient visit, and there's actually a date embedded in there. There's a value we may want to store a JSON object, or we may want to store some mapping data. So we may have a named key which contains some mapping data which maps perhaps city codes to city human readable strings. It's a completely sort of arbitrary open data format, really. The only constraint being it must be serializable to a string. So you can kind of do more or less what you want with it. You can cause as much trouble as we will let you cause with it. But what do you want to use collections for? Well, I'm going to talk a little bit about some use cases just at a very high level now. And then in a few moments time, we're going to jump into a real demo, and I'll get some code running and show you the app, and we'll hopefully have a little bit of fun with it. So one of the big use cases for collections is taking in high volume data. So systems which may send out lots of events, maybe every time a patient visits, or maybe automatic reporting from some devices in the field. Very, very high data input, which can be hard to deal with in its own right. But that can be ingested in OpenFunction via webhooks. So systems will send data straight into OpenFN via webhook. And a collection is a very easy way to buffer that data. So every piece of information that comes in will be processed by OpenFunction. It might be parsed, it might be expanded, it might be added to some other data, and aggregated into a collection on OpenFunction. So you might take something like thousands of incoming requests a minute, millions of incoming requests an hour, and you might aggregate them into like a record of, here are all the requests in the last hour, aggregated and totaled, saved into one single collection item. Which means that downstream, rather than processing a million items, you can only process one item. So this is really useful for handling high volume data input in your workflows. Another big use case is mapping values. If you've ever tried to integrate data between two systems, one of the things that tends to come up all the time is that system A has a value for perhaps a name as first underscore name, where system B will represent a name as a camel cased first name with a capital N, or F name, or something like that. Perhaps name is two fields. So mapping particular values from different systems, one way we often do it is we use JSON structures as lookup tables. So you'll store a key in a JSON object, and the value that you want to map to as the value of the JSON object. And well, maybe you can see where this is going. Collections are a really convenient way to store and edit those mapping objects, those lookup tables. You can save them in a Git repository somewhere. You can share them and source control them. You can edit them directly in your favorite editor. You can upload it straight to the collection. And instead of having a huge, many hundred, maybe even many thousand key long JSON objects stored in your job code, as we often do at the moment, you can just store it in a collection, nice and neat, nice and tidy, out of the way, and you can edit that without having to edit your actual workflow. And another really convenient use case for collections, something that's been we've been discovering after implementing the feature, is it's really useful for sharing data even between, sometimes even within a workflow. So if workflow A produces a certain state object and maybe sends it off to a certain system, maybe when workflow B fires the next day or a couple of hours later, or perhaps even as a direct result, sometimes the sharing of that state can be quite difficult. There's some practical reasons why you can't share state within the workflow, or you can't pass it directly to the next workflow. Perhaps the workflow has 3 or 4 different inputs. Perhaps many workflows do the same sort of thing concurrently and need to all write to a single storage solution. Collections are really useful for that. If a collection writes whatever data it wants to write to a central data source, then that can be shared between the different workflows, and it just can make life an awful lot easier. So that's 3 high-level use cases, but we're really excited and interested to see what people want to do with these collections, how they're used. We maintain a community at OpenFn.org, and we love hearing feedback from you guys, how you're using it, what's working, maybe what's not working, raise bugs, etc. Tell us what you get up to. I'm just going to change my screen up now. We're going to jump into a real demo. I was trying to think of a good use case for what I could do with collections, and I basically wanted like a big data set, and I wanted to transform it a little bit and then process it and maybe put the system under a little bit of strain, see if we can make it sweat. Being an Englishman, my first thought was maybe I could load in the complete works of Shakespeare and handle those. But even for me, that was a little bit of a too boring prospect. But what I did find a little while ago, and I've been desperate to find a way to use this data set, is the complete transcripts of Star Trek: The Next Generation, all nicely typed up onto this website here by some very busy volunteer who I definitely owe a coffee to. And I thought it might be fun to download that data set, process it, upload it into OpenFunction collections, parse it, break it down to different lines, and then kind of generate a random quote from anything across the whole series, and maybe talk about how you might use that data further downstream. So I'll be using these big text, well, biggish text corpuses as kind of just an arbitrary data source, right? But we'll play with them, we'll transform the text, and we'll kind of see what comes out, and it'll take us through some of the nice features of collections as we go. So what we have here then is that the right screen, I think so. This is the OpenFunction app. I hope that some of you are familiar with it. I'm running, oh, you can't see maybe I'll just share my whole window with you, just so you can see the URL, because context is important. So we are running here on demo.openfn.org, which is our online demo server. It's quite an underpowered server, and we'll come to talk about that in a few minutes' time, but this is kind of publicly freely available. You can sign into it with demo credentials, and I'm going to use that live online server now for my collections demo. I'll also note that all the source code for this demo and everything we're going to see in the next 5 or 10 minutes, there's a GitHub repo with it all in, so if you want to download it and have a play with yourself, you'll be very welcome to. So I'm going to open up the collections demo, and I'm going to just talk very briefly about what we're going to do, and we'll jump into some code. So there are 2 workflows within the collections project. One workflow is all about ingesting the script data in the first place and saving it into collections. And the second workflow is all about reading data from those collections to generate a random quote from my favorite TV show, the 1990s Next Generation. We're going to start focusing with the upload scripts workflow here. So the workflow is sort of conceptually very simple. The workflow provides a webhook, so that's a HTTP endpoint which we can call into directly. In fact, if I click on it here, you can sort of see, well, there we go. We can sort of see here the webhook URL. This is a public URL that anyone can call into, and indeed I will be busily calling into it with curl. This triggers this workflow to run. When the workflow runs here, we start at the top and work our way down. And the first thing we're going to do is we're just going to post the scripts one at a time. We're going to take each episode's script and just save it into a collection. I'll avoid the temptation to show you code just now. And then once you've saved it into a collection, we're gonna parse that script and we're going to extract each line from the script. We're going to save that into a different collection with its own key name, and then later we'll randomly pick a line from a certain character to generate their quote from. So it's conceptually a very simple workflow, and actually I am going to show you some code because it's sort of what I do. And also there's not much code here. So in the very first part of the workflow, the webhook posts an episode script to us. We're just going to call, maybe I can zoom that up a little bit for you guys. Maybe that's a bit easier. We're just going to call a simple collection.set function. We're going to set a value in the TNG scripts collection. We're going to generate a key from the script according to the incoming data. We'll talk about that in a minute. And then we're going to upload the actual data into the script. So we call collection.set with 3 arguments, and that inputs the data. Collections are available to every single workflow, but they must be created before they can be used from the admin menu. So in the admin menu here, under the collections, I can see that I've created three different collections for this demo. TNG, that's Next Generation Star Trek, TNG char map, TNG lines, and TNG scripts. We only have a very simple administration interface for collections at the moment, but we can create, edit, and rename collections from here. So let me just bounce straight back into my little project, and let me bounce into my upload scripts. So the first step is just going to literally dump the incoming data into a collection, and the second script has a bit more code in. I am not going to go into super detail, but I'll just roughly run through what's going to happen so that when we talk about things, they'll make a little bit of sense. We take the script we've just received, and we do a little bit of JavaScript here, which we'll split the text as a big string, splits up into a bunch of lines. We read each line and we pull out the character name, and we pull out the thing they've said, the quote, and we save all that into a big old array. So this will be an array of strings, and then we're going to do collections.set, and into our TNG lines collection, we are going to pass in our lines data. And because we're setting key value pairs, and because I'm setting an array of maybe several hundred items, it's kind of tedious to generate a key for every single item or to sort of specify that. So we use what we call a key generator function here. And a key generator function will be called for every single item we want to set, and it will be called, it will pass the item, or actually I should say the value, it will pass the value into the function, and we return a string which represents the key we want to use to save that ID under. And actually I'll show you here, because in our parser we generate the key as an ID. I won't save this, but I'll just scribble this in because perhaps this is actually slightly clearer. Variable names are important. So up here we're going to generate our key, and we're going to generate our key as a sort of hash of the character name, the episode number, and the line within that episode, so that every single line of dialogue from every single episode of the script has a completely unique key, so we can refer to it independently. We can also use this information to search the keys, as we're going to do a little bit later on. So we just take that key value, and we use that in the set. And then we do some other stuff with the character map, which I will come back to a little bit later. The character map, if I have time, will let me explain a good use case for mapping. But I kind of want to push on and get some code running, so I'm just going to ignore the mapping for the moment. The bottom line is we extract the list of all the character names who are speaking, and for each character name we want to map their script name, which is quite terse. So the character name is just Picard or Data or Torres. don't even know who Torres is, whatever, it's not important, Joe. We want to map that terse name into a real human readable name, and we're going to use the character map for that, and we'll spend a minute or two. Okay, so what we're going to try and do now is we're going to run this first stage of the script. So I'm going to switch my screen again. I'm now showing you my Visual Studio Code, which is on my my little code repo for this project. And there's a bunch of things in here. So I have downloaded into my little local repo. I've downloaded all the scripts as HTML files. So just to show very quickly, here is the raw data as text. We have a little script in TypeScript actually, using Bun, which is an alternative to Node.js because I'm JavaScript hipster or something. This little script, which is almost irrelevant to this demo, but this reads in all those HTML files and extracts the raw script text, and that's what's going to actually upload. Somewhere down the bottom here, you'll see. No, you won't. Where will it? Can't remember my own code. Okay. Dun, dun, dun. There it is. Yeah, someone here will send a regular fetch request to the webhook of the open function endpoint, and we'll just stringify our data there, and that'll run for every single episode, and you'll see that in the logs in a minute. I've also got on my repo the complete project that you just saw in open function. So all of our projects are saved as project.yaml files, YAML just being yet another markup language. It's a bit like JSON, it's just a way of capturing key value pairs again, and nested key value pairs. And this defines everything that you just saw in open function. All the code is actually defined here. The actual source code we save in files next to it. So if I go to, we haven't seen that code. So if I go to parsescript.js, this little file here is my actual JavaScript code that we just saw. So I can represent this code in as a local JavaScript file on disk, or I can represent it in Open Function Platform. And from disk with the CLI, I can actually deploy straight from here, from the project.yaml. I can deploy this code and this workflow straight to a running Open Function instance somewhere, which I've done in the creation of the demo. This is how I set things up. And if you were to check out the repo and play yourself, you'd be able to go through exactly the same steps and get it running on demo or your local instance. But the reason I'm here now is because I actually want to run my little upload script. So I'm going to run my little TypeScript file with bun upload.ts. Oh, and I will just say, full disclosure, I am at the moment limiting the amount of data I'm going to upload. I'm not, so there are, I don't know, 250 scripts or something. I'm only going to upload the first 50 because it takes quite a long time to process all the things. So you'll see in a moment, the upload is very quick, and even the processing is fairly quick. But because the demo server is quite low powered, it takes a bit of time to chew through all the work, and we're not going to sit on the call and wait for that. But on my local machine, processing all the raw data of the web takes, I think, maybe a minute and a half, 2 minutes. So not very long at all. But all we're going to do at the moment in my terminal shell here, I'm going to upload script. And this is parsing. So you can see in the shell here, it's reading my episodes from disk. It's extracting them, uploading to open function. It's 50, and it's generated 50 work orders on open function and conveniently given me the name, which I hope is the right one. So if I switch my screen back now to platform, yeah, I had a feeling that would happen. Okay. So I'm looking at my history on the demo, and there are no waiting work orders, which means something went wrong. I think I already know what's gone wrong there, because just before I started this demo, I reset the whole project. So I just need to copy out the webhook. You can't see my screen, but I'm just going to paste that back into the source code, and I'm going to run the script again. There we go. And now you can see suddenly we have 50 work orders all sitting here waiting to process. And this is all quite good fun. We should start seeing them getting processed. There we are. So you'll see on the right hand side here, the work orders are all uploaded and processed almost instantly. Lightning will ingest them, and then for each for each work order that comes in, for each script page that comes in, it's going to run our workflow and it's going to process every single page of the script. If I just open this one up to show you, we can inspect in the app the full logs. And the logs are quite noisy. There's lots of low level stuff about what's happening, but I'm just going to skim down, and you will see down here we get to the start. So this is parsing episode 113, the big goodbye, classic. And we can see, just to show what it's doing, we have logged the very first line of the script. So it's taken the character name, the episode number, we've generated our key, that unique ID number, we've taken the actual line, and we've taken the title. And we do that for 347 different lines for that one episode. And we upload those 347 values into our collection, each one with its own key name, just like this. And then we update our character map, which I probably shouldn't be talking about, but it's logging every character that's spoken in this episode. We'll save that back to the collection, and then we're finished. And that's processed the whole thing in well, not very long, a few seconds, a couple of seconds. The actual parsing script seems to have taken about a second to parse and process and upload to the collection. So it's a really, really fast service. If I go there, we're still busy kind of running through one at a time and processing all that data. Now, while that's running, I don't actually need to wait for it to finish. We'll talk a little bit about our get quote. So now we have in our collections store a whole bunch of script data, and I'm going to use this get quote workflow to pull a random quote from it and print it to the console. So the first thing I need to do is just take a little, well, no, let's talk about the code. So the first thing we're going to do is we're going to get from the lines collection, we're going to use a key pattern. So this will generate something like, it's quite sort of nested syntax here, but we are generating a JavaScript string, and the string will be something like the format of star, Picard, star. So that will search for any, where the star is like a wildcard, and that will search the collection's keys for any keys that match that particular pattern. So any key with the word Picard in it. That will give us all of Captain Picard's lines. We're also going to get the character map, which we probably will talk about. Once we're done, we're going to log that we've done it. We are going to randomly, so this is going to pull out, I don't know how many lines, we'll pull out a certain number of lines by Captain Picard. We will randomly pick one of those lines. So pick a random integer, pick the nth number from the array of lines, and pull out the quote from it. And then we're going to do a very simple console.log, so we can see it in our output here, and then that'll kind of be it. What you would do in a real workflow is you probably do something more with it. So once you've got your quote, well, I'll talk about that in a second. Let's get it running. So I'm just going to pull out a little JSON object that I have on my system here. So the webhook works when it receives a request from outside the system, and that HTTP request will have a payload, and that payload will have a character name. And I want to use that as the character name to build my little Picard query here. So I'm going to simulate the request by putting this data structure in. Of course, you might have another service entirely which does this. You might run this on a cron job, or there's all sorts of ways you could actually run this particular step of the process. You could do it from curl, you could do it from the CLI, but I'm just going to do it from the platform here. And I'm going to create a new work order. And I'm going to have a little look at my log, and we can see the job running in real time. So let's have a look. We're downloading data from TNG lines. It's downloaded 3,985 lines, which all match the Picard string. And then it's picked at random the line Wesley from the episode When the Bow Breaks by Captain Picard. Now, the reason we have the mapping in place is because the actual script for the name Picard, for Captain Picard's lines, just has the word Picard on them. I'm just going to bounce back now to my editor for the final little step where we're going to talk about mappings here. So we bounce back to the repo. Lovely jubbly. We don't need any of this around. Fantastic. And what we want to do, instead of just sort of saying Picard all in lowercase, I want to have a nicely formatted character name. And to do that, I can only use a mapping. I am going to run a command using the OpenFunction CLI. So we have a local CLI service which does all sorts of things with the OpenFunction platform. You can run jobs and all sorts through it, but it also has collection support. So I'm going to call it OpenFunction collections to call out to the collections. I want to get, and what I want to get is the TNG char map collection, and I want to get everything from it. And I want to print that collection to a file. I want to print it to mappings / what did I call it? Chars.json. Of course I did. So this is going to simulate what we were just doing in job code. This is going to call out to the collections API on Lightning, and it's going to pull the data down and it's going to save it into that file. And hopefully my environment is configured to use demo.openfn.org. I'm actually just going to put some logging on this just so that I can see what we're doing. We'll run the script. Fantastic, that seems to have done the right thing. So that's called out to demo.openfn.org. It's received my mapping data and has written it to disk. Oh, I should have pretty printed that, so I'll just add pretty to here. Fantastic. So this has downloaded the character map data. And I can see the list of all the character names that are featured in our script, including some very strange parsing artifacts like this. I'm not quite sure what's going on with that. But I want to make a change. Oh, no, sorry, I made a small error. I don't want to download everything from the character map. The character map is a single object, so I just want to download the single value, so it's not nested like that. Do excuse me. So this mapping contains all the character names, and it will allow me to create my own manual mapping as a human. So I want to say Captain Jean-Luc Picard, best captain ever. And having edited my character map, I want to then post it back. And that will be a very similar command to the one we did before. I want to do open function collections set. I want to set to the TNG char map collection. I want to set the character map key to the value found in my mapping file here. And that has upserted back. And that means the mapping's loaded into the system now. And that's where our slightly mysterious mapping code, which I haven't explained properly, will kick in. So I'm going to jump back to the platform. I'm going to run my get quote command again. So I'm still going to send this character Picard data up. I'm going to run it again and cross my fingers. There you go. So now the quote we generated includes the full character name. And the reason it does that is because we have used our mapping data, our mapping object, to map the script name to a human readable name. So it's a really nice simulation of what you'd actually do in a data integration where you're mapping two very different values to each other. And that chars.json file with my mappings, I would expect to be checked into a repository maintained by humans, updated every now and again, completely offline and disconnected from the rest of the system. And then that mapping can just be used almost seamlessly by the job itself. And that's kind of it for my silly little demo. What I hope that showcases is uploading data to collections, downloading data from collections, using patterns in keys to pull out a particular set of data from collections, using the CLI to get and set and update mappings, and how mappings can be used in data integration. And I hope that all made some kind of sense.
Thank you very much, Joe. Maybe we've got a few more minutes. We're just gonna ask if anyone has any questions relating to this, and then we can, answer those, and we can probably take maybe 2 to 3 questions at max. And yeah, if you have any other questions, you can actually post them on community, and we can always respond to those directly. Yeah, so do we have any questions? Please, if you have a question, you might just signify by raising or posting the question in the chat. Thanks, Joe, for that.
So if you want to try and follow along and replicate that, I've posted a link to the repo in the chat. You can download the repo, download the CLI, download Lightning if you would like. There are some in-depth but hastily written instructions which should talk you through how to do everything I just did in that call.
Great. So we don't have any questions. I mean, Joe mentioned this earlier. So currently, collections is not available on the cloud-hosted OpenFn, but it's available for all open source users right now. So if you want to try it out, you can, install OpenFn locally or set up on your machine and actually test. But definitely, very early next year, it's going to be rolled out into the cloud-hosted environment and be available for all users to use as much as possible. Great. If there are no questions, I would say thank you so much. Oh, okay, yeah. Thomas, if you've got a question, what's the storage backend? Joe, do you want to take on that?
Yep. Yeah. Currently, we use Postgres. We may evolve that in future. We may make it pluggable, but at the moment, it uses Postgres.
Yeah, and I think that's also important to know that the OpenFN platform itself uses Postgres, so it's leveraging that same infrastructure that you have existing. Does that answer the question, Thomas?
Yes, thanks.
Great.
Thank you, Kiefer. It's been fun to build, fun to play with.
Yeah.
I have a question which I think we may have already covered, but I was multitasking, if I'm totally honest. Where does this show in, like, could we look at it in situ again in terms of like how it shows in the UI?
Yep.
And
So
if I was
So currently, there is no user interface right now for interfacing. Only admins can.
Yeah, there's just this little bit.
Yeah, so it's currently only available for user admin, the super admins, which is one of the reasons why it's not been rolled out fully to all users, especially on the cloud-hosted environment. I mean, if you're using this within your organization, you can easily talk to your instance admin to actually create, update your version and then create, collections for you to be able to use within your organization. But if you're using the OpenFN cloud, which is the cloud-hosted environment, you have to wait till sometime early next year for you to be able to use that. And that's where definitely then come with allowing you to be able to create collections yourself, administering that within your projects, and then also be able to think around viewing or exploring the data that you have directly in there as much as possible. But yeah, so we're really still building. There's a lot of development work that is happening. So we're very curious to hear, your use cases, comments that you have, some of your fears, just let us know so we can actually factor all of that into, how we build as much as possible. Thank you.
And if I had some feedback, where would I go to raise?
So there's community.OpenFn.org, so it's typically where you'd get all the feedback. You can post your questions here, and also if you have a feature request, so there's a feature request category that you can actually just make a feature request directly. So it might be related to collections. In some cases, not collections, might even be a random feature request that you might have. So feel free to be able to post that in there But one thing you can be very sure of is, someone within the community will be able to respond to you in a few hours, as much as possible. Great. I think that is that right now. Thank you very much again, everyone, for joining. Like I said, this session is recorded. We're gonna upload the video, and it will be made available on the community for anyone who needs to, and would also send that, as an email, after now. Thank you so very much for joining.